Good morning, Algebra 1. This is Mr. Morales. I'm going to be going over the day one review for our 6 weeks common assessment. Most of this review is going to be done with the calculator. I mean, you could do it by hand, but that would kill too much time, and that's not really the focus. So let's go ahead and jump right into it. Here, I want to find the solutions for these 3 quadratic equations. In a quadratic equation, in order to solve it on the calculator, and the keystrokes we're going to use for quadratics are menu 3, 3, 1, and then you press OK. That's the keystroke selection. That's the quadratic formula function, basically, built into the calculators. In order to use it, you need to have 3 values. You need to have the number of x squares, or your variable squared. In this case, I have a 1 x squared, so I have 1. You need a number of just plain x's in this case. I have no x's, so I would say I have 0 of them. And then you need to have a constant attached. Be very careful. You pick whatever sign is attached to your number that's all by itself. So in this case, my constant, my c value, will be negative 49. So I'm going to put in 1, 0, and negative 49 into the function calculator. So I'll press menu, 3, 3, 1, enter. And then I have 1x squared plus 0 x's plus negative or minus 49. Make sure you always double check that sign. When I was grading this assignment, I saw people had no solution. That's because they put a positive 49 in the calculator. So you press OK. It gives us the equation, x squared minus 49. That matches the equation we had here originally. Whoops. Now go ahead and press enter. Negative 7 and positive 7. So my solutions would be x equals, it doesn't tell us how to write it, so I'll go ahead and just use the regular set notation. That's going to be negative 7, positive 7. All right, so that's number 1. Let's go ahead and go on to number 2. Same exact thing here. I have a single x squared, because we're measuring everything in x's. For b, I have no x's, and my c value is negative 121. I want to address something really quick. In this equation, it's equal to 0, which is what you want. Over here, it's equal to y. The reason why I can treat it like a 0 is because since x is the only thing in the main part of my equation, y is basically just a placeholder saying your answer. So I can make it anything I want. In this case, the answer I want is always 0 for these types of problems. So since there's no other y inside the equation, I can go ahead and make this single y or any other letter that's not inside the equation just a 0. That's why I did that. So, but I digress. Back to number 2. So my coefficients and constants are 1, 0, and negative 121. Menu, 3, 3, 1, enter. It's 1 x squared plus 0x minus 121. Making sure not to forget the minus sign. Let me go ahead and press OK. I see it in my equation there. It looks exactly like the one I have up there. So go ahead and press enter. Negative 11 and positive 11 on solutions for number 2. X equals, in bracket form, negative 11, positive 11. I have a little more space. There we go. And number 3, finally, to be done in the same fashion. So now I have 2x squares. So my a value is going to be a 2. I have, once again, no x's at all, so I can say 0. And then my constant is this positive 11, so I can just put in regular 11. 2, 0, 11. So I go to menu, 3, 3, 1, enter. And then I have 2 x squared plus 0x. And I believe it was positive 11? Yes. 11. Okay. 2x squared plus 11. That's exactly what my equation says here. Oops, and I caught myself right now. It says equals 43. I didn't follow my own rule of checking if it equals 0. So I'm going to have to get rid of this 43 by subtracting it. Now 43 is just a number, so it only affects stuff on the left side that are just plain numbers. Since this is an x squared, it's not going to be affected. But since this is just a number, it will be affected by that minus 43. So 11 minus 43. That's going to be, what, I think 43, 33, 32, I believe, negative 32. But let's see, 11 minus 43. Always check. So I can go ahead and not even bother with that anymore. Okay, let's go ahead and go to, what was my equation? 11 minus 43. Negative 32, correct. So, to correct myself, negative 32. Look what an easy mistake that is, even for someone who's an old veteran like me. Shame on me for not checking my standards. I always have to make sure it equals 0 first. So 2, 0, negative 32 should now work. Menu 3, 3, 1, enter. 2, 0, negative 32. Enter, okay, okay. 2x squared minus 32. That's exactly what I get when I subtract the 43. So my solutions are at negative 4 and positive 4. I'm not going to get into the different ways you can write the same answer. This is the basic format. So there's 1, 2, and 3 for you. Please identify whatever mistakes you might have made. And if you have any misunderstandings, please ask them before the test. Number 4, after reviewing it at my first period, I realized I don't like the way it's written. So I'm going to go ahead and just omit it altogether. It has issues that I really don't want to take the time to address. And the test will not have anything, what I think is poorly worded like this. So moving on, number 5. So now I have 0 equals x squared plus 4x plus 3. So let's follow the standards for solving this quadratic. Does it equal 0? Yes. Does it have all 3 pieces? Yes. Let's identify those pieces. Whoops, while I make you dizzy. A equals the 1x squared that I have. B equals the 4x that's shown, positive 4x. And C equals the positive 3 that's attached at the end. 1, 4, and 3. So I'll use the same exact functions that I used before. And 1, 4, and 3. I'm like Dory this morning. I remember the numbers I just used. 1, 4. All right, don't get that. There you go. And 3. 1, 4, 3. Okay, it should look like that. X squared plus 4x plus 3. X squared plus 4x plus 3. Correct. Press enter. Negative 3, negative 1. That means this graph would have x-intercepts at these 2 points if we were to graph it. Number 6. Let's follow the same criteria, shall we? Does it equal 0? No, it equals 2x squared, positive 2x squared. What would remove that positive 2x squared to make it a 0, you ask? Subtracting 2x squared. Whatever I do on the one side of my equation, I have to do to the other side of the equation. So on the left side, 2x squared minus 2x squared says equals 0. And then I have to go and ask myself, will this negative 2x squared affect my negative 3x? And the answer is no. It can only affect other things with x squares. So everything will just get attached to it the way it is. Now I have my 3 values since it equals 0, and I have all 3 obvious pieces. Negative 2 is my first coefficient. For b, it's negative 3. Remember, don't forget to look at those minus signs. And then I have positive 2. Negative 2, negative 3, positive 2. So let's go ahead and just review how we solve this. And I'm sure I don't remember already. Negative 2, negative 3, positive 2. Negative 2, negative 3, positive 2. All right, let's see what I get here. Negative 2 and 1/2. Hopefully these answers you guys are getting, especially you, Miss Sophie. Shout out to you in my video here. Good morning. All right, and let's see, number 7. We have it in the same format that we need. All 3 pieces, it equals 0. So let's go ahead and just identify everything. My A is going to be a 4. My B is going to be a negative 9. And my C is going to be a 3. 4, negative 9, 3. 4, negative 9, 3. 4, negative 9. Don't do this to me. There you go. Thank you. Just gotta not rush it sometimes, right? 4x squared minus 9x plus 3. That's exactly the equation I have there. Press enter. And I get this stuff. That means I'm going to have to use quadratic formula. So for this one, and I did tell the other classes that until first period. So for this one, let's go ahead and use the formula. X equals negative b would be a positive 9 plus or minus the square root of, let's see, over 2 times a. It's going to be b squared minus 4ac. Let's go ahead and figure out what the discriminant is, which is actually what that inside piece is called. B squared minus 4ac. So negative 9 squared is going to be 81 minus 4 times 4 times 3. So I'm going to have negative 9 squared minus 4 times 1 times 3, I believe. 4, 1, 3. Yes, yes, yes. That seems to match. Oh no, wait, 4, 4, 3. Thank you for double checking my work, Mr. Morales. You're welcome. All right, 4, 4, 3. There we go. That's way better. And we get a 33. So my final answer for this is going to be x equals. So I want you to leave it, because the square root of 33 is not a perfect square root. So let's go ahead and leave it in that form. 2 times 4 on the bottom is 8. And this is exactly how you'd be expected to do it on the test. Okie dokie, so let's go ahead and move on. Number 8, which I just drew over the screen for no reason. Let's move it up so we can see it better. Number 8, we have an equation that models the height of a basketball t seconds after it's been hit. How long was the ball in the air? All right, so let's go ahead and take a look at what the graph looks like. Negative 16t squared. So remember, in order to graph it in the calculator, what we're going to have to do is, first of all, make sure it's equal to 0, which this h you can use, because the rule I told you before is if it's not in the equation, you can go ahead and make it 0, as long as there's just one of them. So we have negative 16. We can't graph t, but we can graph x. And we'll replace all the t's with an x for in the calculator. Negative 16x squared plus 58x plus 3. Graphic side, negative 16x squared plus 58x plus 3. Does that sound right? Plus 58x plus 3. Yeah, that's right. So let's go ahead and enter. There's the height of one bounce of the basketball. Basically what you have here is the basketball kind of going up this line here and then back down over here. It goes up. It's a maximum height and then comes back down. We want the time right here at the x-axis. Now it's between actual numbers. It's between positive 1, 2, 3, and 4. To get the actual amount, here's the best way to do it. Menu, trace for 5, graph trace for 1. Now I'm going to go ahead and just scroll to the right until it gets to where I want to go, which is the other side of when it falls back down again. So let's go ahead and see. And it should actually take us to a part it calls the 0 itself. The time is right here on the bottom left, 3.68 seconds. So time equals 3.68 seconds. There we go. Now, that's enough of quadratic equation, or excuse me, quadratic formula and quadratic solving for now. Let's kind of work backwards a little bit. Now we're going to practice multiplying binomials, or in other words, FOIL. Remember what FOIL stands for. It's the method we use to solve these types of things. It stands for the first term times the first term. 3x times x would be 3x squared, because now there's 2 x's involved. The outer terms, outside 3x times outside 6. 3x times 6. 6 groups of 3x will give you 18 x's. Inside terms, 1 times x will give you a positive 1x. And then the inside times the last term, 1 times 6 will be a positive 6. 3x squared cannot be combined with anything else. However, these positive 18 x's and plus 1x will give me 19 total x's with a plus 6 that can't be combined with anything else. And there's my quadratic equation. Number 10, x plus 4 to the second power. That means I have x plus 4 times x plus 4. So when I do the FOIL method here, x times x gives me x squared. X times positive 4 gives me positive 4x's. Inside terms, 4 times positive x is positive 4x. Positive 4 times positive 4 is positive 16. The x squared in this equation, or expression, can't be combined with anything else. Plus, I have a total now of 8 x's that can be combined because they're the same. And I have a positive 16 that has no other numbers to be combined with. So there's my equation there. Number 11, same exact method again. X times x is x squared. X times negative 6 is a negative 6x. Positive 6 times x is a positive 6x. And positive 6 times negative 6 is a negative 36. X squared can't be combined with anything else. These x's can be, and since they're opposites of the same amount, they actually cancel out to 0 of them. So I have no x's represented anymore. And I have this minus 36. This is a very special kind of quadratic equation called a perfect square. So that's possible, and that's what it looks like. It's not that big a deal, so don't freak out if you get something like that. Now, number 12, going in reverse. We have to factor these quadratics. Here's the way it works. Now, the thing that holds up most students is if they don't know their times tables. Sorry to break it to you guys. You thought maybe you got away from it when you left 3rd grade, but it's back on to you again. So to make this x squared in the equation, you have to have an x times x. That's always the easy part. Then we have this negative 10. This negative 10 is crucial. We need 2 numbers that multiply to make that negative 10 and add up to make a positive 3. I know, because I know my times tables pretty well since 3rd grade, that 5 and 2 have a difference of 3. Now it's just a matter of attaching a sign. I know I want more positives, so it's going to have positive 5 times 8, negative 2. Positive 5 times negative 2 equals negative 10, And positive 5 plus negative 2 equals this positive 3. Here are my factors. All right, now let's go ahead and look at number 13. It's the same exact thing. To get an a squared, I need an a times an a. To get a positive 60 and a negative 16, I know I'm going to have a 10 and a 6 involved. 10 times 6 is 60. I need to get a negative 16. So what I need is two negatives in this case. A negative 10 times a negative 6 will give me a positive 60. A negative 10 plus negative 6 more will give me negative 16 total. So a minus 10 and a minus 6. For number 14. Whoops. I want to keep my pattern going, so I'm going to change the color up a shade, as I've been doing, because it brings me joy when I do notes. All right, so number 14, I have the same exact process again. X times x will give me x squared. What will give me a 64 when multiplied and add up to an 8? Both positives, positive 8 and positive 8. So I can leave it like that, or I can write it as the same thing times itself. Be prepared to see it either way. If you're not good at these, your best bet then is to look at your multiple choice answers and do FOIL like we did in 9, 10, and 11 to figure out which one gives you these actual equations that are shown above. All right, and then finally my last two. Number 15, use the quadratic formula to solve. Easy enough. It equals 0 and I have all three pieces. A will equal positive 3. Whoops, that's a check 3. There you go, 3 comma. B equals positive 11. And C equals negative 8. So X equals, quadratic formula is negative B, which makes this negative 11, plus or minus the square root of B squared, which is 11 squared, minus 4 times your A value, which is 3, times your C value, which is negative 8, all of that over 2 times your A value, which is 3. When you get these problems on the test, just go ahead and go, let's go ahead and the square root will determine how far we can actually go. 2 times 3 on the bottom is 6. So let's determine this square root. 11 squared minus 4 times 3 times negative 8. So back to my calculation side. 11 squared minus 4 times 3 times, was it negative 8, I believe? Yes, it was 4, 3, negative 8. Enter. 217. Let's check out the square root. 217 is a nice even number, or a nice whole perfect number. It is not. So what I'm going to go ahead and do is just leave it as square root of 217. A lot of students ask, how will I know if that's how I write it? Look at your answer choices on the test. If you see them in this form, then just stop when you get to that point in the equation. That should be easy enough. And number 16, it equals 0, and I have all three pieces. So my A value is 1, my B value is negative 7, and my C value is positive 9. I really can't see this color that well, sorry guys. So I have x equals negative b, which would be a negative 7 would be a positive 7, plus or minus the square root of b squared, negative 7 squared, minus 4 times 1 times 9. All that over 2 times 1. So this I suspect will be very similar to the one previously, so I'll set it up to go at least that far. Negative 7 squared minus 4 times 1 times 9. Negative 7 squared minus 4 times 1 times 9. 419, all right there in a row. Double check that's what it's supposed to be. Yes. And I get 13. Obviously not a perfect square root. And so I get, well, that's pretty much my whole answer. 7 plus or minus the square root of 13 over 2. So hopefully that helps you with your test. Please review and ask any questions if there's points of confusion. Good luck, guys.